Okay, so here's our 787 number from 0.787 number from before. So what are we going to do to simulate this? What would you like to do?
Well, if we ran this a lot of times, it could be maybe like 1,000 times.
Okay, so we'll do a for loop. For I equals 0, I less than 1,000. I plus plus.
Yeah.
Alright, and then what are we going to do in the simulation?
So we have to roll 3 dice. Oh, first we have to pick a number.
Okay,
so
what do you want to call your number?
Maybe like A, and then we could have it be 2.
Let's do random integer 6. I think that's the command, but let me check. So random integer 6. Oop. Looks like I can pick zeros with random integer 6.
Yeah.
So I probably want to do random integer 5.
And then we have to add 1 to it.
Sure. Okay.
And that's going to be the number we pick at first.
Alright.
So then we have to roll 3 dice. And then we have to kind of set some sort of counter. So if we all 3
that's a good point. So let's make a count equals 0. Let's make a counter that starts off at 0 in the beginning.
So then we have to roll 3 dice.
Okay, what do you want to call those numbers?
B, C, and D.
Okay, so what, I'll just copy this.
B, C, and D.
B, C, and D. Alright, sounds good. Alright, now what do we want to do?
So, then we have to write out all the possible probabilities. So, we have to say if B, C, and D all equal A.
Yeah, we do, you're right. We have to check how many of them equal A.
So we have to so if we check, like, how many of them equal A.
Okay, so what's the first thing we should do?
Well, we have to write the case for all 3 being equal to A.
Alright, so what would you do?
So we could say if B, C, and D all equal A.
And then what we would add?
And then we would add 30 to the counter.
Okay. Yeah, we could do that. That's going to involve us checking if 3 equal A or 2 equal A or 1 equal A or 0. But we could do it a different way. We could check, first we could check, does B equal A?
Yeah.
And then what could we do next?
If C equals A.
And then?
If D equals A.
And then we would know how many were equal.
Yeah.
Okay, so let's do that. So if A equals B, add to the counter.
Well, we need to add.
Because the counter is going to, what's the counter going to tell us?
It's the amount of money.
If A equals C, and the counter A equals C. Okay, so we need 2 counts. Money equals 0.
Yeah.
Okay, so this counter is counting what?
How many of the numbers are equal to A? So.
That's right. So now that we're gonna know, so if count is 0, what should we do? To money.
Money minus 10. It's 10, and then if count equals 1, money equals money plus 10. And money equals money plus 10 is 20. And plus 30.
Okay. And now since
we have minus 30.
oh yeah, good catch. All right, so now that we're in a loop here, we have this problem that count is going to be some number here. But what do we want count to be when we go back to the beginning of the loop?
We have to reset it. So maybe we could, if count equals 0, if we could put things at the end of these if statements, then like subtract the count by however many.
Well, yeah. Oh, we can wait to do it at the end though. We just want to check because only one of these is going to be true, right?
Yep.
If it's either 0, 1, 2, or 3. So now at the end of this, what do we want to set count equal to?
Count equals 0.
Count equals 0. Okay.
All right.
And then we do that 1,000 times.
And we want to.
That's our for loop.
And then we want to average the money or
Okay.
divide the money by 1,000.
All right. So now money. We just print out money divided by 1,000, and that should be our things. And we're hoping to get something like 0.79. Ha! Look, and we ended up getting. Is that on the screen? We ended up getting minus 4/5.
Which is 0.8.
Percent. Okay.
We only got
Right.
1/50th. That one's around.
Yeah, so it's bouncing around a lot. So how do you think we could improve our simulation here?
If we added more trials.
Okay, how many do you want to do?
Maybe 100,000.
All right, sounds good to me. Money divided by 100,000.
This could take a little while. No, 0.78. 0.71. 3. These are all pretty close.
Okay, yeah, so that narrowed it down a little bit. And let's just for fun, let's try.
A million?
You think 1,000,000 will be too slow?
Not really. .78.
That's pretty good. Does that give you confidence that our initial mathematical modeling was pretty good?
Yeah, I think we did pretty well.
Yeah, I think we did too. All right, cool. Hey, so now would you like to play this game with me? I'll be the carnival barker, and you be the player.
No, I would do it if I was the carnival barker.
Oh, you would? Okay. All right, cool. High five then. Great work.